Very good morning, students. Today we are taking the topic components of a vector. So we are already see different type of vector and definition of the vector, and also we learn addition. There are two law we see: addition law for triangle and parallelogram. Now we next topic that components of a vector. In that we have particular see how we can distribute the vector. Let we can consider vector A be a given vector. Let vector A be the given vector and lambda be the scalar. We are given a vector and a scalar. Now how do we multiply this? Then the product of a vector by a scalar is denoted as lambda into vector A. So product we can write lambda into A is for the multiplication of a vector by a scalar. Clear? It called the multiplication of vector by a scalar. So simply we have to magnitude is multiplied lambda into vector A. So we have to multiply the magnitude lambda of scalar lambda with the vector A. Here this quantity is also a vector. Is also a vector. Lambda into vector. So product of a vector by scalar gives again a quantity which is also a vector and collinear to the vector A. Lambda into vector is collinear. We already see definition, which is parallel to same, or both are parallel. So lambda into vector A collinear to vector A, that is given vector. So product of a vector with the scalar gives you a vector quantity which is a collinear to the given vector. The vector lambda A has the direction same or opposite to that of vector A according to the, so you can say direction of lambda into vector A is same or opposite to the vector A according to sign of lambda. So the direction of this vector, that is lambda into vector A, is depend on the sign of lambda. If lambda is positive, then if lambda is positive, so direction of lambda into vector A is same as the direction of vector A, but if lambda is negative, value of the lambda is negative, the direction of lambda into vector A is opposite to the direction of vector A. So if lambda is negative, then direction will be opposite to that of the given vector. So this is very important. If lambda is positive, the direction of lambda into vector A is same as the vector A. But if the lambda is negative, so direction of the lambda into vector A is just opposite to that of the direction of the vector A. Clear? And magnitude of vector, these are very important points, that's why I am writing magnitude of lambda into vector A is lambda into or mode of lambda times the magnitude of vector A times the magnitude of vector A. So one can say the magnitude of this vector, that is lambda into vector A, is mod of lambda times the magnitude of vector A. So one may be written as mod of lambda into vector A is equal to mod of lambda into mod of vector A. Mod of lambda into vector A equal to mod of lambda into mod of vector A. Now similarly you can say geometrical visualization of multiplication of a vector by a scalar. Suppose if you find or if you write in terms of geometry or geometrical visualizations of the multiplication of a vector by a scalar, like suppose we are given a vector A. This is the vector A. Clear? Now suppose you multiply this by 1 by 2 or lambda equal to you take 1 by 2. So half magnitude is changed half, means 1 by 2 into vector A. So this will be remains direction same, but quantity remains half. Magnitude is reduced. Suppose this is 5 units, then this will be 2.5 units. Magnitude is changed. If we are multiplying lambda equal to 1 by 2 with vector A, then it will be this. And if you are taking lambda equal to 2, so we have vector twice of this. Direction is again same, lambda equal to 2, then if you multiply with the vector A, then 2 into vector A. So magnitude will be twice. Now if lambda equal to minus 1 by 2. So this will be minus 1 by 2. So direction is changed because this is negative. As we are taking the positive lambda, then it will be same direction as the given. This vector A and vector 1 by 2 of A both have same. Or vector A and 2 into vector A both have direction same. Only magnitude is changing. But when you take negative of the lambda, we have already given the definition. If minus is there, then the direction is just opposite to previous, and magnitude is half. So this is the. Similarly, you can write minus 2a, minus 2a. So again, this direction is changed and magnitude just double of a. So here direction toward this side. Now direction for negative will be toward this side. Magnitude for suppose this is 50% and this is 100%. Twice is there. So in this way one can find the multiplication of a vector with the scalars. So in this way you call the lambda equal to suppose minus 1. So lambda into vector A, that is minus 1 into vector A or minus A. So we get what? The negative of this vector is A, then minus of this negative. So we can say minus vector A is the negative vector or called the additive inverse of vector A. So what we can write here point? Point says the vector minus A, the vector minus A is called negative or you call the additive inverse, also called additive inverse. It is called additive inverse of vector A. So we have a property for vector, already we see additive inverse. Vector A plus minus vector A equal to 0 vector, or minus vector A. So this is very important property we see. Vector A plus minus of vector A means sum of or addition of vector and its negative always gives you the 0 vector. Clear? Now also if lambda equal to, if we consider lambda equal to 1 upon mod of vector A, if we are taking a special case in which the value of lambda equal to 1 by mod of this, and also we can say this mod or scalar not equal to 0, or vector A is not 0, or you can say vector A is not a 0 vector, then we have very important property, that is mod of is equal to mod of vector A, mod of vector. Now we can put the value of mod of vector A, 1 upon mod of vector A. So what we get, 1 upon mod of vector A into mod of vector A. So both are scalar, that's why divide we get 1. So in this way we can find that the modulus of this is 1. Mod of lambda into vector equal to 1. So we know that if the magnitude or modulus of a vector is 1, that vector is called as a unit vector. That's why lambda A represents the unit vector. So this is a unit vector. Lambda A is a unit vector in the direction of the unit vector is same as the vector A. So we write it as any vector. If A is a unit vector, then we can write A cap equal to vector A divided by mod of A. If a vector is divided by its magnitude, we get a unit vector. A cap, this representation or this is the symbol of unit vector. So unit vector, as you know that having magnitude 1, but by formula how we can write a unit vector? A cap equal to vector A divided by magnitude of B. Suppose we are given any vector B, then what is the unit vector corresponding to B? So vector B cap equal to vector B divided by their magnitude. So this is simple formula to find the unit vector in the direction of the given vector. So B cap equal to vector B divided by mod of vector B. So this is all about the multiplication and some simple properties of the vectors. So we take the topic component of vector. So let us take the points. We are taking 3 points in the Cartesian system in 3-dimensional geometry, that is x, y, z. This is x, y and z, and this is origin. Now suppose we are taking 3 points on the coordinate axis. A, B, C. So we are taking coordinate of this 1 0 0 1 0 1 0 0 0 1, because when we are taking any point on x axis, its x coordinate will some scalar, y and z coordinate will be 0. So we can write here A as 1 0 0. When you take B on y axis, then y coordinate is some scalar, other will be 0. So 0 1 0. And C again similarly we can say z coordinate is scalar, x and y is 0. And we are taking the distance from origin to each point is 1 unit. Clear? This distance is 1 unit. That's why coordinate of point A 1 0 0, B 0 1 0, C 0 0 1. Then clearly if you represent the vectors, this is OA, OB, because this has magnitude as well as direction. So what we can say, magnitude of vector OA is 1, magnitude of vector B is also 1, and magnitude of vector OC is 1. So each vector has magnitude equal to 1. That's why these are called as unit vector. So vector OA, vector OB and vector OC having magnitude equal to 1 is called unit vectors. Called unit vectors along x-axis, y-axis and z-axis respectively. So what is the meaning of the unit vectors? Vector having magnitude 1 and along the coordinate axis, like x-axis or o-x-axis, y-axis or you call y-o-y, z-axis or oz. These are the unit vector OA, OB, OC. Direction is already there from O to X, O to Y, O to Z. So it is understandable. OA means along the x-axis, OB means along the y-axis, OC means along the z-axis, and these are universally accepted or denoted by I cap, J cap and K cap respectively. Clear? These are called as unit vectors. I means vector OA. OA can be written as I, OB can be written as a J, and OC can be K. So here cap represents the unit vectors, means their magnitude is 1. I, it is understandable, it is the unit vector along the OX. J, unit vector along the Y. K, unit vector along the Z. So one may be write like this, I, J and K. These are the unit vectors along the coordinate axis. Clear? Now suppose we consider the position vector of any general point. These are the only, we are saying the unit vectors along the coordinate axis. Now suppose we take a point P in the three coordinate system, then say this is x, y, z. Here suppose this is point P. Having the coordinate as generally x, y, z in coordinate system, and you join with this, that is OP is the position vector of P. Vector OP is the position vector of point P. Clear? Now we can take, let P1 be the foot of perpendicular drawn from point P on XOY plane. What is P1? P1 is the foot of perpendicular drawn from the point P to the plane XOY. Clear? And now suppose we see that P1P is parallel to Z1. If you see figure, this P1 is parallel to Z. So as you know the direction for this I, J, K, these represent the unit vector along the XY axis. It only gives the direction. Now whatever the length if you take, suppose you are taking some distance, this 5 units, then this can be written as y into j. Suppose this can k and z into k. This suppose unit x, then it is x. These are the vectors ox and xy, oz, zk, oy and yz. Because I, j, k are simply unit vector having the magnitude 1. But when you take some more length than 1, then they can be represented in the form of vector xy. So now this vector is parallel to this vector. So one may be written in this way. Clear? And if you are taking points on the coordinate axis q, s, if you take here q and join this, here we have s, like this. If you take the vectors OP1 with the r, and we can make a paralleloparallel in this way. Join this to make the paralleloparallel, or cuboid you can say, simple language. Clear? Now we are drawing this position vector generally we represent as a r. So vector OP equal to vector r. Now in this OQP1, this mark point as a R. So in triangle OQP1, using triangle law of addition, see in this one OQP1. So direction is here important. OQ, vector OQ plus vector QP1 is equal to OP1. So now this is already given as OQ is xy. Sorry, x I cap plus, now value of this vector is parallel to y axis. So y z have its magnitude and vector. So this can be written as yj. OP1 we want to find. Now if you see in this vector, in triangle We have already said this is ZK. This is parallel to ZK. P1 is parallel to this. That's why whatever length of this cuboid side, that will also equal to this. Similarly, this side opposite to this side opposite to this. So if you see in this triangle, so in triangle OP1P, again by triangle law of addition. So you can see here again direction. OP1 plus P1P is equal to OP. So we write OP1 plus P1P is equal to OP. Clear? Now you put the values from 1 OP1. OP1 can be written as xi plus yj. So xi cap plus yj. Now P1P is given by vector z of k is equal to OP. So what is the OP means vector r. So this is very important. What we get, vector r can be written as xi cap, yj cap, zk cap. This is known as components of a vector. We are dissolving the vector r in the form of vectors. This point OP or corresponding vector r can be dissolved according to x-axis, y-axis or z-axis. Or you can say the vector r can be written in terms of their components. That is vector r equal to xi cap plus yj cap plus zk cap. So this form of vector is called as component form. Component form. So what is mean by component form of a vector? It should be represented in terms of x-axis, y-axis, z, or it can be represented in the form of unit vectors multiplied by some scalar I, j, k. Multiply scalar x, y, z. So here we called x, y and z are the scalar components. Here x, y, z are called scalar components. Scalar components x, y, z are called as a scalar, and xi cap, yj cap and zk cap are called vector component. Vector components of vector r. This is very important. What is the scalar component and vector component? Scalar component only we take x, y, z. Suppose I am writing vector r equal to 2i plus 3j plus 4k. So if anyone say what is the scalar component of this vector? That is 2, 3, 4 is the scalar component of the vector. And vector component x into I, y into z. So in vector component there is a direction, magnitude as well as direction. So vector component of this vector 2 iota I cap plus 3 j cap and 4 k cap. These are the vector component of the given vector. Clear? So we can say sometimes x, y, z are also termed as rectangular component. Sometimes we call x, y, z are on some textbooks you find that x, y, z are also called as rectangular component because this is a rectangle. All form as a rectangle or faces are in the form of this rectangle. That's why these are length of a rectangle. Now length of any vector is usually determined by applying the Pythagoras theorem. Now suppose if you want to find the length of this vector R, so we can note that in right triangle OQP1. OQ, this is a right triangle. Why it is a right triangle? Because here 90 degree. So in right triangle, if you are using the Pythagoras theorem, then mode of OP1, this is mode of OP1 is equal to root of sum of square of other two sides, that is OQ plus QP1 square. OQ square plus QP1 square. So if you see in this and using the Pythagoras theorem, we find the modulus of OQ square plus Q. Now OQ is xi. So mode of xi square plus. So we know that mode of OP1 x square plus y square. Why we write x square? Because here I square, that is unit vector, magnitude is 1, 1 square, that is 1, 1 into x square, j square, magnitude is 1, 1 square, 1 into y square. So we get, now similarly you can use Pythagoras in this. So again you can what say? Mode of OP square equal to root of OP1 square P1P whole square. Now OP1 square, mode of OP is root. So if you take square on both sides, so square and square root cancel. This OP1 square, then it will give you x square plus y square. P1P square. So what is the value of P1P? That is ZP. Its square, that is Z. So finally what we get? OP equal to this. So modulus of vector R or mode of R is given by x square, y square, Z square. So in this way one can find the mode of the vector in component form. If we are given a vector in component form, we can also find the magnitude of the vector. This is clear? How to find the magnitude of a vector? Suppose we are given this vector or this vector. So magnitude of this vector is given by formula mode of R, mode of xi plus yj plus zk, or root of x square plus y square plus z square. Now especially if you want to find for this vector R, for example root of x square is 2 square, 3 square, 4 square, and simplify you get the answer, root 29. So in this way, dear student, one can find the vector into components form, as well as after finding the vector in component form, one can find the modulus or magnitude of the vector. In next video we see how to find the direction of this vector or direction ratio or direction cosine. So that we see in that video. So thanks for today's video. Have a nice day. We will continue with us.